So, hey everyone, we are Team 7, and our project proposal for the final project is open source Python library coding agent. So, overall, our idea remains the same. Basically, the background is that when users use Python libraries, they look up documentation online and then they follow a series of steps to get started with the Python library. So, we want to do this multi-step process into a LLM-powered agent where users can simply, through natural language, ask for code and then understand API functionality, as well as access curated resources of documentation or tutorials. So, with respect to the feedback that was given, we were asked to implement feedback regarding using getting started guides and quick starts that can be generated dynamically based on the user's use case. And also, if we can commit the code directly to the user's GitHub platform. So, based on that, we have included two deliverables where one is the user can generate quick starts and tutorials based on the user specific use case. And once he generates those tutorials, he can also commit the code directly to his GitHub repository. And the stakeholders remain the same, where students and aspiring developers are the ones who are using this platform. So the challenge with our current problem is that all these Python libraries have limited number of documentations, so a limited number of quick start guides. So only for those use case we can follow those quick starts. But if we want to generate a quick start for our own use case, it is not available. So that is the opportunity which we are trying to capitalize on by generating quick starts and tutorials based on the user's specific requirements. And going over to methodology.
Yeah, so for methodology, it too remains almost similar. So for methodology, we have just included, the Airflow part remains the same, where we clone the repository and parse things. But for parsing the GitHub repo, we are going to use some new libraries called Git, Python, and Matica based on the suggestions provided by the professor. We are going to use those libraries to parse the code structure, but the underlying R plan remains the same. And then when coming to the front-end architecture, we are going to include the GitHub part as well. So once the quick start guide has been generated, we'll push the particular code changes or that generated part to the GitHub repo, user's GitHub repo. That will be automated through front-end. And then the coding agents remains to be the same. Only thing is like we have added this image like where it goes on to a feedback loop. Once the code has been generated, we'll ask another LLM model kind of a agent to test whether that particular code would like is best performing or will there be any changes, and that will go into a feedback loop, and the code will be the most optimized solution will be captured. And then going on to the SQL agent, like we want to like further explain on why we chose the SQL agent, because it's mainly because of the chunking strategy. So the RAG agent, we have to chunk it and we have to like put it in the vector database. So while chunking, there might be a chance like a function may be split, or a single function may be like split into two entities, maybe two chunks, which may be inaccurate when you are trying to fetch that particular chunk. So, but if we store it in a SQL kind of structured format, we can just store a particular function, and whatever um, code belong to that particular function, we will be able to like fetch the whole code, which we can send it to the LLM, and the LLM can use the full code to understand and provide us the most accurate solution. So that's the main reason why we are trying to use the SQL agent. And the web search agent also remains the same. We are just going to like integrate the same thing, but we'll explain more on the user flow now. So yeah, so the application basically will start from the login part. So the user can log in. If the user, this is the first time if the user is using, they can register to the application and they'll be able to log in. After logging in, the landing page will show like what are the features of this particular application, what the user can do in a detailed way, and they'll be given an option to choose a library like we actually what we thought of doing is like maybe we can try to give the particular URL kind, I mean, option for user to like give the URL of particular documentation and we'll scrape through things. But I mean, for now, as far as we have seen, like scraping the documentation takes like more than 5 to 7 minutes. Like we'll first stick to just like implementing our own predefined libraries, but we'll check the feasibility of whether this can be automated. Like any given Python library, we'll able to scrape or not. We'll just try to explore that option as well. And then I mean, after choosing the library, the user will be provided like with three options. One is the code generation assistant, a quick start guide, and the error correcting agent. So when it comes to the code generation assistant, user can provide a particular use case. So based on the use case provided, the coding agent will come up with the optimized code with the feedback loop which we mentioned before. And yeah, the user can use that particular code to do whatever things they want to do. I mean, the code will be generated on based on that use case they provide, and the user can actually provide feedback to us like whether the code generated was like accurate, whether that satisfied their use case or not. With that, we can just like see how accurate our model has been performing, our agent has been performing. And again, yeah, it goes into a feedback loop. Like they can again like generate whatever code they want. And when it comes to quick start guide, yeah, based on the library selected, we will generate a quick start guide, and the user can actually even ask some questions on a particular parameter or function, how that particular function works, and what are the different parameters that can be played along with. So those they can ask the agent, and it will actually generate the content and explanation for that. So this quick start guide, users will be able to like push into GitHub so that they can like come later, and this quick start guides can be like added to the GitHub repositories to like understand later like how it has been, how this can be used like that. Yeah, again, going to the error correction agent. So here user can actually put in the actual code and the error that they have been like getting. So using the web search agent and other tools we have, will be like generating the optimized code, and we'll be providing explanation why that particular code failed. So this again, yeah, user can again choose a different library and they can actually, yeah, come back again. So yeah, we'll jump into the Jupyter notebook right now.
So for the Jupyter Notebook, the EDA remains more or less the same. We're passing all the code into different table into a table and getting it in a structured format. So the only change which we have done for the architecture is using Claude as our code generation LLM. As we can see that it generates a significant amount of code just by a simple prompt, where we have asked to build an agent which can input a PDF and generate essays. So a RAG agent has been immediately generated just based on a simple prompt. So Claude is being used for the code generation. For testing, we're using OpenAI, which is what we have tested our uh, mm, notebook as well. And similarly, even the Markdown content is in the structured format as well as the Python notebooks. We'll jump over to the Git part of the EDA.
So we have provided a UI where a user has to insert his GitHub link where he has to ask a question for that, and we are cloning that Git using a Python Git library. Uh, can you just scroll it down? So initially we are extracting the code index and the code text from that GitHub repo mentioned by the user, and we are cloning it with the Python Git. Scroll down, scroll down. Uh, and over here, we are able to extract the code index as well as the code text, which will be going into the Pinecone database. And we are splitting the text of the code text, and we are pushing that onto the Pinecone database, and we are able to query that thing. We are able to retrieve that the index from the Pinecone database. Also, the second part is where when the user make any changes and has to push the code back to his GitHub repo, So again, we are using Git Python library, and from that we are importing this repo function, and we are able to pass all the we are able to push the update onto the user or any open GitHub repo. Moving on to the
So the project plan and timeline remains the same. We're dividing it into 5 milestones, and they have set dates for each phases as well. The responsibilities of each team member also more or less remains the same. Uh, yeah.
And in terms of risk and risk, so uh, more sort of the risk remains the same. The one risk that we identify was the incorrect or partial code generation, where we are using where a LLM will provide any incorrect or functional code, like partial function codes for any use cases. So in that we are implementing like human in a loop approach, where the code which is generated are being verified by the user before they finalize or complete the any tutorial or guide. And more sort of the outcome, again we have mentioned the three agents that we are using. uh, More sort of the benefits and the outcomes remain the same, and also for the conclusion as well. And this is the end of our final project proposal.